This session we will be learning a very important concepts in Linux. This is file permissions. So in Linux, everything is a file, a directory or a device connected to your machine. Everything is file. So with the power of file permissions, we can give access, or we can revoke access, or we can restrict access for some files or devices from particular users. Let's see the use case first. So here I have created a shell script. I will try to run this. Okay, so we got the output as permission denied. So why is it so? This file is been created. It has a shell script also inside it, but the current user cannot access it because it doesn't have a permission to do that. And how we will know that? If we do ls-l, see, so ls-l lists the permissions of all these files starting from the second character here. The first character denotes D as in directory and hyphen for files, and all these 9 characters denotes the file permissions. Just to see the file permissions of greet, we can do ls-l for now. Here these file permissions are divided into 3 groups each. There are total 9 characters here. First 3 characters are for the user or the owner of the file. Next 3 characters are for the group of the owner, and third group is for the rest of the world or the public. What does that mean? So every user can be a owner of a file, or every file must have a owner. Also, a user can belong to a group. Suppose all the administrators of your system can belong to one group, all developers can belong to one group, all testers can belong to another group. So Linux gives us a powerful method to control their access. How it is done? As I said, the first 3 characters denotes the user, and here you can see R and W is already there, which means the user has a read and write permissions. But there is no, the third character is hyphen, which means there is no execute permission here. So there is a command chmod u as for user plus x to, we are giving execute permission to the user. If I run this command, and then if I run ls-l greet.sh, you see the third character has become x. That means now the user has a permission to execute this file. Let us see. So it is asking for a name, and I gave a name and then I press enter. It says hi Bob. So it's a very small script. We will learn how that is also created. Now let us see what are other file permissions in this directory. As you can see, for file 1 we have read and write for the user, read for the group, and read for the all others. That means the owner of this file, which here is Lokesh, can read and write this file, but he cannot execute this file one. Let us try to do that again. It says permission denied. So you got my point now. So if there is an X, which means execute permission, then only that person can execute the file. Are there any other files? Yes. With X, see here, the date command has a X for the user, for group, and for everyone else. So anyone can execute this date command, but there is no W here, no W here. That means except the owner, nobody else can write into this file. So this is the way the file permissions work. They are divided into 3 groups: user, group, others, and inside these groups there are three permissions: read, write, and execute. And to be um, to be more familiarized with the chmod command, we will do some more ownership changes for some other files. Let us see. uh, we have a file info to which the user has only read and write access, no execute permission. So the which we already did. We did a chmod and u plus x and give the file name, so that gives a execute permission for the user. See, this access appeared now, so user has the execute permission. But if you want to give a execute permission to others, we have to do g plus x info. So others means it has to be O here. So others belong to the third group here, which doesn't have an execute permission right now. See here, here the third column is the for others, and it doesn't have an execute permission. After running this command, if I do ls -l info, so others also got the execute permission, but not for the groups. So now let us see how we can uh, take away permission from the user. Similar, and it is very intuitive. You can do others -x file name. If we do ls -l now, sorry, ls -l info, so it has taken away the execute permission. Same way we can work chmod command on the group also. So right now the group has just the read permission. We want to give write permission for anyone in the group. We can do g for group plus w for write and info. If we do ls -l info now, we'll see the second column with three permissions, the write has been added to that. So this is how permissions are given and taken away from a user or a group or everyone else for a particular file. There is another method to give file permissions to any file or directory, that is called a numeric method. For that we have to consider these three things. Read is equal to 4, write equals to 2, and execute equals to 1. We'll see how this works. If I check the file permissions for read.sh, here we have read, write, execute. The group has just the read permission. Now if you want to give group as a read and write permissions, so we have to see here, read and write means 4 plus 2, which is 6. So if we do chmod, before that the owner already has a read, write, and execute all the permissions. That means 4 plus 2 plus 1 is 7. So we have to give chmod 7, which belongs to the owner or the user. Then for the second column we want to give read and write permission, which is 4 plus 2, which is 6, and we'll keep read permission only for others, which is 4. So if we give 764 greet .sh, only change would be we will be now giving write permissions to the group. So here the W has been introduced. So this is the numeric way to give file permissions. Let us see some more examples. Let us take some file which doesn't have much permissions. Okay, so if we see, it has just read and write permissions for the owner, read permission for others, and just the read permissions for others. Now remember, read is 4, write is 2, and execute is 1. So if we want to give execute permission to all or to others, here we have to give, and we have what we can do is, already the read permission is there, which is 4. So for others we have to give 5. For owner it's already read and write, that means 4 plus 2 6. chmod, for we don't want to change any permission for the own user, so it will be 6. For group it is read and we want to retain that, so we'll just give 4. For others we want to give read and execute permission, that means 4 plus 1, which is 5, and then the file name. Now if we do ls-l file2, see the execute permission has been given to all others. And what happens when we create a file by default? Suppose I create a file using touch command, and if I do ls-l new file, it will be given a default file permission, which is read and write for the user, read for groups, and read permissions to everyone else or others. So this is a default file permission which is being set by the administrator or the default operating system through a concept called umask. So this umask decides what will be the default permissions of a file created from a user. So this umask varies for user to user or group to group. Now here, if we just ignore the first 0 here, this 0 belongs to the first 3 characters, this 2 belongs to the group column, and last 2 belongs to the other column. How? We know that read is 4, write is 2, and execute is 1. Knowing this, if you subtract all these characters from 6 or 0, 6, 6, 6, you will get the default permission like 0, 0, 2, 2. You will get 0, 6, 4, 4. So 6 means read plus write, that is 4 plus 2. So the owner has got read and write permission. Group is 4, that means read only, and so group has got read permission, and then same for the others. So this is how the umask decides what will be the default permission for a file created by a user.